Good afternoon, and thank you all for joining us for our webinar today as we take a look at Markforged's biggest and most capable printer yet, the FX20. Today we are joined by CAD Micro's VP of Advanced Manufacturing, Deep Singh, and William Gacke, our Additive Manufacturing Engineer. Before I hand things over to Deep to kick us off, there are a couple quick housekeeping items to mention. First, as usual, we'll save a few minutes at the end of today's session for a question and answer period. Feel free to type your questions into the GoToWebinar panel as they come up, and we'll do our best to get to them all at the end of today's webinar. The webinar will be recorded, and we'll be sending you the recording via email tomorrow. So if any questions do arise afterwards, you can feel free to respond to that email, and we'll be in touch shortly. All right, without further ado, I will pass things over to Deep to get us started.
Thanks, Madeline. Actually, I'll get started here with the agenda, and I'll pass it off to Deep afterwards. So first, Deep will be talking a little bit about CAD Micro Solutions as a company, what we provide and what we stand for. Afterwards, I'll be doing an overview on the Markforged technology. We'll take a deep dive into the FX20 components and what makes it really special. And we'll take a look at some of the additive manufacturing applications for this printer. So my name is William Gacke. I'm one of the additive manufacturing engineers at CAD Micro Solutions, based out of Calgary, Alberta. And of course, I'm joined by Deep. He's the VP Advanced Manufacturing. So not just 3D printers, he also takes a look at metrology, scanning, and AR and VR. Now I'll pass it off to Deep now.
Hi, good afternoon, everyone. It's very exciting to be here. We're doing a product launch for Markforged, and William's going to be walking us through that. CAD Micro, we're 100% Canadian-owned business. We've been around this engagement for about 38 years now, serving across Canada from 5 different offices. And we got some brilliant people like William who are helping sort of support our clients and make sure that the implementations go smooth, that we're here to help them with their journey. And our mission is really to enable our customers to innovate and succeed by providing them with Industry 4.0 technologies that are going to be beneficial for their business. And our commitment to our clients, we like to work on every project as a customized solution. We understand that not every implementation is same for everybody. So, whatever your needs are, we will assess your functional part requirements. We'll look at your requirements based on the technology expectation that you have and work with you collaboratively. We have reliable resource and support across Canada to help with the implementations. And we're always proactively looking at new technologies. And part of my initiative is to look at Technology Watch program, where we're evaluating technologies before launching it to the market. And that's a very exciting program because it allows us to test and validate any equipment that we're supporting to our customer. So, it's a commitment from us to make sure that we're providing you with reliable, easy to use brands that are going to be providing value in your business. And the 5 areas of our business today that we operate in, we have the design software capability. So with the Soul System Solutions and 3D Experience platform, there's some really powerful software under that wing that allows you to create your CAD model, like SolidWorks, for example. But 3D Experience platform is becoming really powerful, where you're able to do simulation of your designs and create function-driven generative design that now complements 3D printing. The area that Will and I are part of is the Advanced Manufacturing division. And under the Advanced Manufacturing, we have additive manufacturing equipment, we have software, hardware, post-processing, anything to do with that ecosystem where we can provide value. Advanced simulation is another division of our business. Whether you're looking for flow sim or structural analysis or CFD analysis, we have tools and capabilities where we can help you there. My colleague Rob Johnson oversees the metrology division of our business, where we represent a range of different 3D scanning solutions that help you with reverse engineering or part inspection capability. And then the final division of our business is immersive technology, AR, VR, XR, and such. And we're using similar tools to get to rapid support with our customers. So by deploying AR, VR, we can virtually assist where we can't be in person times, of emergency. So there's some really interesting things happening in that space. And finally, this is a quick little snapshot of our overview of our additive equipments that we represent today. We're really in the three different technology categories in additive: the vat photopolymerization, material extrusion, and powder bed. But we can hit applications anywhere from prototyping to rapid tooling to rapid manufacturing in both polymer as well as in metal 3D printing. So there's a range of different tools that we represent. The one that we're going to talk about today is definitely our Markforged partner and their FX20 printer, why that's so different and exciting. So I'm going to pass it back to William to kind of take us to the journey of this new exciting FX20 printer that's been introduced by Markforged. Over to you, Will.
Thanks, Steve, for the introduction. First, we'll start off talking a little bit about Markforged. So they were established in 2013 in Boston. Their founding team comes from MIT, and they're also the creators of continuous carbon fiber 3D printing. Of course, they're industry leaders in enterprise adoption and enablement, and they went public last year on the New York Stock Exchange. So when we talk about Markforged, we're really talking about three different areas. So their software, their printers, and their materials. And that's what they call the digital forged. For those that are unfamiliar, it's their platform consisting of their hardware, software, materials designed to work seamlessly so that engineers can go from design to functional part with ease. The platform is connected and it is smart with software that enables organizations to scale and distribute their additive manufacturing operations and realize the vision of a digital supply chain. So one main component of their digital forge is the industrial materials. They have a wide range of proprietary materials that unlocks a broad set of applications. So we'll be kind of focusing on our continuous fibers here. So your carbon fibers, Kevlars, and your fiberglasses being combined with a plastic to make a strong end-use part. One plastic that is standing out right now is the Ultim 9085, which is capable on the FX20. Markforged also offers metal printers, which they have all different application uses for these different materials. Software is another component of the digital forged. I want to briefly touch on the recently released Markforged simulation software. It's baked right into Eiger, so before you hit print, you can validate part performance as well as optimize print settings. This results in saved material and reduced print iterations. It'll actually visually show you the deflection of the part in the simulation as well, so you can show it in a presentation for your colleagues. And before we dive into the hardware of the FX20, I think it's important we talk about the technology that differentiates the printer from the rest of the industry. That's continuous fiber reinforcement technology. While most other printers can use, let's say, a chopped carbon fiber within a plastic binder, so like a carbon fiber filled nylon, we can actually lay down continuous fibers into a part through a second nozzle to create parts that are approximately 10 times stronger than a standard fused filament fabrication part, or FTM part. And it's capable of replacing machined aluminum. So if we take this part here and slice it across, you can see now we have a cross section. This is just the top view of that same cross section. And this is that cross section as shown in Eiger, which is the slicer for Markforged. You can see in the white here, that's your plastic material. So typically this is a carbon fiber nylon, or in the case of the FX20, it can also be an Ultim. The yellow on the outside, this is your reinforcement material. So this is Kevlar in this photo, but it's a continuous fiber that's actually placed into the part. After it's done printing, you can see the fiber laid on the perimeter of the part. These continuous fibers allow for tremendous strength and distribution of energy within parts. And here's a really good graph to visualize the strength gains. It's a stress strain graph. At the bottom, you can see your matrix materials. So things like nylon, ABS, onyx, which is carbon fiber nylon. And as you go up in stress, you can see the benefits of the continuous fiber reinforcement. If you need something that's strong and ductile, you can go with something like Kevlar. You need something that is maybe halfway and it's also high temperature resistant, you can go for high strength, high temperature fiberglass. And if you want to replace aluminum parts, you can go for a carbon fiber like this. Here's a cool video. This is a link that was reinforced with continuous carbon fiber and is being tested on a tensile testing machine. It can actually withstand over 2,200 pounds before breaking. You won't have any audio on this, but you can visually see it break. So yeah, for a little link like that, that is insane strength. Here you can see the size difference between the Markforged machines. The FX20 is engineered from the ground up to bring the continuous fiber reinforcement process to a whole new range of parts. It's capable of printing high temperature thermoplastic parts with continuous carbon fiber for high strength aerospace grade parts at the click of the button. The printer delivers improved performance and consistency to unlock the most demanding manufacturing and end-use applications. Here's a video showing the behind-the-scenes development of the FX20, and it really shows the development and the thought process of the engineering team.
So we're about to go look at something that no one outside of Markforged has ever seen before. This is top secret.
FX20 is the most ambitious product Markforged has ever taken on.
Bigger, faster, hotter, smarter.
We really set out to build the best printer ever for engineers by engineers.
The number one request from our customers has been they want to print larger parts. Going bigger is really hard. When you expand things in X, Y, and Z, you encounter all new challenges. By going faster, you need stronger motors. When you have stronger motors, you need a stiffer motion system. It makes the technical challenge exponentially harder.
The mass goes up, which means controlling the thing becomes more difficult. The FX20 is massive. We made this thing several times larger and that problem got way more difficult. This is what the printer looks like on the inside. This is an enormous mass that has to move up and down. It needs to be in the exact right place so your part comes out the way that you want it to.
In addition to just going bigger, you really need to go faster, otherwise you'll be waiting a long time for your parts.
FX20 will allow you to do everything you're used to, but you're going to be able to do so faster, much faster.
With FX20, we're able to go multiples faster without reducing surface quality or finish or accuracy of our parts. And when it comes to hotter, we're enabling FX20 to print Onyx, Onyx FR, Onyx ESD, nylon white, all of our continuous fiber reinforcement materials, carbon fiber, Kevlar, fiberglass, high strength, high temperature fiberglass. Plus it'll print
Ultim 985 filament,
which is our first high temperature thermoplastic that allow our customers to address an even wider range of applications that they've never been able to address before.
This is going to allow people who are currently 3D printing parts and putting them into airplanes and really bring those up to the next level.
High temperature thermoplastics like Ultim filament are really the top of the polymer pyramid.
we're not the first to print Ultim filament.
We're adding continuous fiber reinforcement to it to give it the strength of metal. Totally changes the game. Lastly, Smarter. Our platform, the Digital Forge, continuously gathers data, and we've developed FX20 to capture orders of magnitude more data. Once you have that data, you can use it to control the printer and create ever better parts.
There's optical sensors in there, and based on that, we set the speed of the extruder.
Yeah, buddy. Love it. This printer has more sensors on the print head than all of the sensors on our previous printer combined, capturing all the data that that machine needs to learn, get better, and deliver the perfect part.
This is a printer that's going to continue to get better over time. The day you buy the FX20 is going to be the worst day it ever performs. And it performs really well from day one. So we have a motto here, which is that the part is the product. And that's been central to the development of FX20, from the size of the parts the speed with which you can print them, the materials that you can print, and ultimately the quality of those parts.
Markforged is known for making real parts, and that's our key differentiator. We bring the function, and form, fit, function, those are like the core things in engineering, and the FX20 is going to take that to the next level.
The surface finish on our parts is better than anyone else's, and there's this tight association between what does the part look like and how high quality of a part it is.
One of the challenges to achieving a really good surface finish is differences in the bed position of the thickness of my hair will show up in the part quality. And we've been through 4 different iterations of this print bed, chasing down that thickness of a hair, and we actually had to reinvent the entire print bed in order to accomplish that. So we redesigned it from the ground up, and we have a much better product now. We're making this bigger, faster, and hotter. We are not making it any less accurate.
One of the defects that we see that are problematic is Z-banding. This is when your system is not mature enough to be able to move the bed at a consistent layer height. It got better. This right part here is a current printer. After we've implemented a lot of hardware and software improvements, and this is the kind of surface quality that we expect to ship with this printer.
The FX20 engineering team is just a dream team of cross-functional engineers that are top of their class in every discipline. So we solve things in a very systems engineering way.
So every time you look at a Markforged part and it looks beautiful, that didn't come for free. That's literally thousands of hours of engineers staring at these parts under a microscope, fine-tuning every detail of the system in order to achieve that piece of quality. And this is the same approach Markforged takes on every printer and every product.
The products we're designing are for people like us. Customers that wanted to rapidly iterate functional prototypes, that want to manufacture products. And what we're doing with FX20 is really taking it to a whole new level. Super excited to see FX20
Start shipping to our customers in 2022 so they can build with it.
and start creating value for them and their customers.
So I'll reiterate a couple of things from that video. Obviously, it's a bigger printer. It's 4.5 times bigger than the X7. You're able to simplify multi-part assemblies into a single part. So this saves you significant time breaking up CAD files. If you don't necessarily want a large part, you can always print more parts on a single build. It's also extremely fast. It's up to 2 times faster than the X7 at turbo print speeds. And this is without reducing part quality. If you're comparing to default print speeds on a Mark II, it's actually 8 times faster. So what this means is you get a quicker time to part and ultimately a higher throughput. And to help you digest what that means, here's an example of a printed part across the Markforged lineup. So this part here, it'll actually take 3 days and 18 hours on the Mark II. But on the new FX20, that part will only take 1 day and 9 hours. So this means that a part that almost took a full week can now be printed in the morning and used next day. And I'll just tell you a little story. So I went to the CAD Micro Solutions office back in October in Toronto just for some training, and I got to see the FX20, got to see the huge parts that could be printed on that machine. But it doesn't just print parts, large parts quickly. During my training, we needed a part the same day, so we started a print on the FX20. We left for lunch, and by the time we got back, it was finished. So this part here in my hand, probably the size of my fist, it only took 45 minutes to print. It's really good for iterations and doing quick design changes. The FX20 also has improved temperature capabilities. So this allows for printing high temperature thermoplastics and being reinforced with a continuous fiber. So Ultim 9085 as a material, it has high heat resistance, good chemical resistance, and it's also flame, smoke, and toxicity compliance. These properties enable it to be used in end-use parts in industries like aerospace, defense, transportation, automotive, and oil and gas. So it's an incredible material on its own. But by taking this versatile material and reinforcing it with a continuous carbon fiber, Markforged unlocks more applications and enables customers to go beyond by printing off semi-structural parts. And lastly, as they said, the printer is smarter. So the digital forge itself, it's able to leverage data from past prints to improve the future prints. Markforged customers have over 10,000 cloud connected printers, and they're always adding more. So to put that in perspective, right now, every 10 seconds, a new part is printed on a Markforged printer. And every print generates metadata. This drives insights and makes the platform better, which gives improvements to the entire fleet. So the FX20 was built around this philosophy. So extensive system instrumentation provides rich end-to-end process visibility and performance data. So insights previously impossible to discern become clear, and this really allows Markforged to push over-the-air updates. So this improves performance, increases reliability, and enhances overall user experience. Like the behind the scenes video said, the first day you'll receive the printer, it'll be the first it'll ever be. So finally, we'll take a look at the machine itself, taking a look at a couple of the components. I'll mention that a lot of these animations and details are available on the Markforged website through their virtual tour. So first, we'll take a look at the build chamber. So what's really important, the heated build chamber provides an ideal environment for quality and consistency. Having a heated build chamber opens up new material capability and allows existing materials to print better. This thermal uniformity also enables for more consistent properties throughout a part, as well as improved dimensional accuracy. When you're dealing with Ultim filament, it also has a best-in-class warm-up and stabilization time. One really great feature for the actual build chamber is the automatic calibration. So typically installers will just level the unit once, and afterwards as an operator, automatic calibrations are done for an adaptive first layer, as well as automatic XYZ offset calibrations to locate the nozzle. It also features a single reusable print sheet that's the same for all Markforged materials. So it doesn't require any specialized cleaning procedures, and this enables safe and easy part removal. It's been tested for hundreds of parts, so you're not replacing the build sheet every other print like other printers. And now we're going to talk about the printhead. So the printer comes with 3 nozzles. From left to right, the printer has a plastic nozzle. In the middle is your fiber nozzle, and on your right is your B plastic nozzle. It's a direct drive extrusion system, and it has an advanced materials and heating system for maximum conduction and control. One really great thing about this is there's no module or nozzle changes required when switching between current materials, so the same nozzle for every material. It's also a tungsten carbide nozzle tip, so that means they don't wear out with use. You'll be using the same nozzle. It's also future-proofed. So the current plastic nozzles work for Onyx, Ultim filament, and the support for Ultim, but it can be extended as the machine evolves. And each module can be easily swapped. So if there are any developments in the future, you'll just be taking out the nozzle and putting a new one back in. Next, we'll talk about the motion system. So it's a ground-up precision machine design. You have linear encoders. These have a 2-micron resolution and gives real-time feedback on the head location. The physical gantry, of course, is rebuilt. So you have larger motors, you have beefy circular rails, and more robust hardware throughout. An important detail that's often missed in high temperature machines is heat shielding. So this gantry has it's shielded from the majority of heat from by these baffles here, and it's cooled through the back. But even then, it's still built to function in high temperatures. These high temperatures also result in faster printing times with Onyx, so your carbon fiber nylon material. At the bottom left here, you have optical sensors within the bellows to detect the filament feed rates in real time, and this will automatically adjust. The filament will be fed through into the energy chain into the printhead, and here is also where your continuous fiber reinforcement material is fed through. And here is the material drawer for the FX20. It has 4 independent storage bays. Each bay has a moisture sensor to ensure the materials are kept within spec at all times. These spools are also very large. They each hold a 3200 cc spool. This is actually 4 times larger than a typical Markforged spool. So the 2 bays on the left will feed the A nozzle, and the 2 bays on the right will feed the B nozzle. Currently, you can't do automatic material changeover, but this will be enabled in the future. So overall, this machine is built for ease of use for operators. Number one being you have simple workflows. You don't have any labor-intensive utilities or maintenance, and it's designed for a high uptime. It also has a simple and intuitive UI and software. So here's an interesting little clip here. So other Ultim filament printing solutions, they often require really a difficult process to remove the supports. So for example of this, some users have to repeatedly place a part in the oven to heat it up. They'll take it out, remove a few supports, and then replace it back into the oven to reheat and repeat the process again. The FX20 uses the Ultim breakaway material to simplify this process. And you can see how easy it is from the video on the screen. Here's a demo of the touchscreen of the printer. You'll be seeing that it's very intuitive and simple. You don't need an engineering degree or a technologist's diploma to operate the machine. All the information there is laid out for you. If the machine requires any intervention, it'll actually walk you through the steps on how to do the operation that's asking you to do. So with the large form factor and increased material capabilities, the FX20 applies to more industries. So we'll talk about a couple of use cases here. First, the FX20 will extend capabilities for customers making precision tooling, jigs and fixtures. Second, it also opens up new markets for end-use parts in industries like aerospace, defense, automotive, and oil and gas. This printer has speed, size, accuracy, and the materials and consistency to meet the requirements of these industries. Here are a couple of the applications for the FX20. If we're kind of looking inside of the manufacturing facilities, you can see we have end of arm tooling, consolidated assemblies and closures, and etc. But when we also look at we also have the Onyx fire retardant filament and the Ultim filament. You're now able to use printed parts in high temperature resistance applications. A lot of these same sort of items as well. Outside of the factory floor, we can also benefit from increased chemical resistivity of Ultim in the oil and gas and chemical processing industries. Ultim also allows for printed parts in very regulated application spaces, so like production aerospace, safety critical tooling, and high performance production parts. So if you're looking at the interior of a plane, you're looking at maybe like wall panels, cabinet doors, latches, spare parts. Even behind the walls, you're looking at ducting, housing cable holders, connectors, and brackets. So in summary, this is the FX20. You can print large quality parts at high speeds. It's a production unit ready built for high uptime and reliability. And it's also built for a wide range of industries, from tooling and fixtures to regulated applications. It's the only printer to have continuous carbon fiber reinforcement for Ultim filament. So this results in end-use parts right out of the printer. So that's it for this, this presentation here. We'll open up the floor for any questions.
Awesome. Thank you, William and Deep. That was a great presentation. So like William said, we do have some time for questions, so keep them coming. We do have a couple already that are in the queue, so let's go ahead and get started on those. So the first question that I have here is, why would you purchase an FX20 versus a competitive printer?
So really, there's lots of reasons why you would do that. So the printer itself, it has a lot of capability around reducing downtime. You're not switching nozzles around. You have reusable build sheets, so you're not throwing out a ton of build sheets and replacing them all the time. You have all the automatic calibrations of the printer. It's very repeatable and reliable. You also have the increased material capability. So you have the continuous fiber reinforcement that's not seen on other printers. And you can add this now to a material like Ultim. And as well as Markforged, you're kind of living within their ecosystem. So everything works extremely well together and it's always evolving. For example, they just included the simulation software. Of course, if you're interested in learning more, I'm sure Deep and I would be very open to have a one-on-one dialogue with you. So please reach out and we can continue offline.
Amazing. Thank you, William. The second question that I have is, do prints shrink after printing?
So typically when you're doing or printing in high temperatures like this, so it's like peak printing, Ultim printing, you are going to have some shrinkage of a part. The iGrow software will actually automatically adjust the dimensions of both Onyx and Ultim filament to compensate for thermal expansion due to the high temperature chamber.
Awesome. Now, how complex is the setup process for the FX20?
Yeah, I'll take that question. So when we brought the machine to our facility as a demo equipment, we were really impressed by how easy it was to set up. Effectively, you need your footprint for the machine and then your electrical output required. But that was it. After that, we kind of lowered down the stands and made sure that everything was leveled and the gantries were all calibrated as needed, and walked away with a calibration run that took roughly about an hour or 70 minutes, and it was all automated. It calibrated your different z-axis with respect to your build plate, your nozzles, how they communicate to one another. It was all automated. So I would say in less than 3 hours, you're up and running. We're scheduling currently about 2 days to be on site to do the implementation. So day one, we come on site and do the uncrating and installation and go through the software, and we start a print overnight. And next day we verify that everything's done correctly. But reality is that the way the automated calibration system has been designed, the system is up and running within 2 to 3 hours. So it's really smooth.
Wow, amazing. I do have another question here, and it is, what are the power requirements for the FX20?
Yeah, so it's we can send a spec sheet out, but effectively it's a 3-phase 24 amps, 200 volts. So it's pretty standard for some of the industrial equipment. You are dealing with heated chamber. Your nozzles are going up to higher temperatures. So that's why the power requirement is a little bit higher than some of the traditional Markforged equipment that we've seen in the composites. But the full spec sheet, we have a facility guide that we can share to walk through what's required from a power standpoint. And we're happy to support those type of dialogues.
Awesome. Yeah. So that is all the questions that I see here for today. If any questions do arise afterwards, please do not hesitate to reach out to your account manager or reply to the webinar email, and we'll be in touch shortly. Once again, thank you so much for a great presentation, Deep and William, and thank you all for joining us this afternoon. We hope to see you again soon. Thank you.